Good morning, sir. Myself, I am Paul Reddy, studying in SRIT Engineering College in CSM branch. Now, I am going to explain about program to insert, delete, and display the elements in queue by using linked list. Let us discuss. Content: Introduction to queue and linked list. Basic structures of a queue using linked list. Insert operation in a queue using linked list. Deletion operation in a queue using linked list. Display operation in a queue using linked list. Time complexity analyze. Advantages of using linked list for queues. Disadvantages of using linked list for queues, and conclusion. Let us see. Introduction. Introduction to queues of using linked lists. Queues are fundamental data structures that follows the first in first out principle. FIFO, it means first in first out. Linked lists are dynamic data structures and that consist of nodes linked together by pointers. Combining queues and linked lists allows for efficient insertion, deletion, and display operations. In the above diagram, queue using linked list, the structures of the linked list is available like this. Basic structures of a queue using linked list. In a queue implemented using a linked list, each node contains data and a pointer to the next node. The front of the queue points to the first node and the rear point to the last node. Insertion are done at the rear and deletion are done at the first to maintain the FIFO order. As we are deleting an element from a linked list, it may deletion from rear and inserting from front node. Insert operation in a queue using linked list. To insert an element in a queue, create a new node with the data and set its point to null. And if the queue is empty, set both front and rear to the new node. Otherwise, update the rear's pointer to the new node and move the rear pointer to the new node. Here, while inserting a new node to the a linked list, we need to connect them. Delete operation in a queue using linked list. To delete an element from a queue, check if the queue is empty, front is null. It means while going to delete an element, if the stack is empty, then nothing is there to delete. So we need to check before while deleting an element the linked list. If not empty, store the front node's data, update the front 2 points to the next node, and free the memory of the deleted node. Handle the case where the queue become empty after deletion. Now, display operation in a queue using linked list. Displaying all operations in a queue involves traversing the linked list from front to rear. Start from the front node and move the next node using pointers until reaches the rear. We need to move the new node until it reaches to the rear. Print or display the data of each node as you traverse the queue. Time complexity and analysis. The insert operation in a queue using a linked list has a time complexity of O1 as it involves updating the rear pointer. The delete operation also has a time complexity of 1 since it involves updating the front pointer. Display all elements in a queue using a linked list has a time complexity of n due to the traverse of n. While inserting or deleting an element from a linked list, it must and should be from top position. Advantages of using linked list for queues. Linked list allow the dynamic memory allocation, enabling queues to grow or shrink as needed. Insertion and deletion at the front and rear of the queue are efficient with linked list. Linked list provide flexibility in managing and manipulating queues elements compared to fixed size array. Now, let us discuss about the disadvantages of using linked list. It increased memory overhead compared to using arrays. While we are using linked list, it takes more memory than arrays. Linked list requires additional memory for storing pointers or reference to the next node, whereas arrays allocated memory in a continuous block. This extra overhead in memory can lead to higher memory usage, especially if the queue needs to store a large number of elements. Additionally, linked list can have slightly slower access time compared to arrays, especially for random access due to need to traverse the list sequentially. Now, the conclusion. Disadvantages of using linked list for queues. It increases memory overhead compared to using arrays. Linked list require additional memory for storing pointers, references to the next node, whereas array allocate memory in a contiguous blocks. The extra overhead memory can lead higher memory usage, especially the queues need to store a large number of elements. Conclusion. Implementing a queue using a linked list offers a flexible and efficient way to manage data in FIFO manner. It means first in first out manner. The insert, delete and display operation can be easily performed in a queue using linked list implementation. Understanding the combination of queues and linked list is crucial for building scalable and responsive applications. Thank you.